Well, another sunset. Looks a lot like what we had yesterday on the weathercast. But some pretty colors. We're looking at a change coming up for the next week, so things will start getting active here shortly. Anyway, it's Tim here, and I hope you all are having a good day. Getting towards the weekend here. And what do we got on the surface map? Don't have a very deep fetch of low-level moisture that we usually see this time of year. You can see that we've got kind of a weak northeasterly flow. That's because we've had a succession of highs come down from the Great Lakes area, and that's helping dump a little bit of denser, cooler air into the southern U.S., and then that kind of feeds into Texas from the east. But we've got some action going up north, that's for sure. So you got an MCS here from about Minnesota to Wisconsin, and we have a couple of supercells in Iowa. I've got GR level 2 up right now. And you can take a look at that action right there. We've had a couple of confirmed tornadoes on this in Butler and Floyd County. It looks like it's probably let up a little bit. Maybe if I run this back I can show you how it looked earlier. So yeah, that's more of the kind of supercell structure we were seeing at 34 after the hour, so this was about half an hour ago. And at the time you can see there's a very well-defined hook. So there's that classic supercell shape, and you can see the very strong reflectivity gradients right through here. This here may be an artifact right here, and on the next scan you can see that kind of resolves, but still a very strong reflectivity right there. And if we take the scan higher, you can see a little bit of overhang right in this area here. Looks like the core is right in this spot right there. Go back to the surface, and that's sitting over the inflow area into these storms. So what's causing these storms? Well, obviously we do have a frontal boundary in that area. You can see that on this chart, and if we put the surface observations up, we've got a lot of 60s and a lot of upper 50s and 60s coming into Minnesota from the northeast there. There's a big old Hudson Bay high to the northeast, and that's setting us up with a frontal position about like this. So I can paint that in as a cold front, and this is probably a warm front here in Minnesota or in Wisconsin. And where's the low pressure? I can just go ahead and use their fields, and they've got one low pressure center in northeast Nebraska. But we've got to pay attention to this area here. You can see there's a very weak westerly flow. Looks like southeast of or southwest of Minneapolis, So that would probably put a low center probably right in this area here. I'm trying to remember the names of the towns there, maybe St. Cloud. So even though that's not depicted by a closed contour, we would be looking for that right in that area. And here's another way we can see it. Let's take a look at the Polar Orbiter satellite. This is from about 10 or 11 in the morning. And you can see the classic setup of tropical air flowing to the northeast. And right here, from about the Quad Cities up to the Iowa-Minnesota border, we've got a boundary. And northeast of that boundary, look at that, we've got telltale transverse bands right there. See those? And that's an indication of let's try that again. That's an indication of stability back behind the outflow boundary. So this air here is relatively stable. And we're talking about strictly within the outflow air, within the lowest 1,000 to 2,000 feet above the ground, not the free atmosphere like thousands of feet off the ground. So we've actually got very unstable air overlying this whole area. Now take a look what happens a couple of hours later. Now things start to look very vertical, and you can see the inflow of cumulus from the south, from Missouri, flowing up into the storm area, and then we've got towers in the northern part of Iowa right there. We can get a close look at that right there. It's almost like looking at an airplane window there. Very spectacular. So these storms got going, and they had a very favorable orientation for working their way down the outflow boundary. Sometimes they will depart into the bulk of the cold air, and you'll get a movement like that, and that only gives you a limited window for severe weather development. And look out to the west, Cirrus. That's a sign of some upper level lift working into the area, so I'm sure that was a factor as the afternoon went on. Here's the sounding for Davenport. This is a little bit south, maybe southeast of those thunderstorms. And we can see some very rich moisture here. This is about about 4,000 feet thick, based at the surface. And if we construct our lifted parcel, let's see, what kind of temperatures did we have there? We need to check that out. Okay, so we're panning the map up to Iowa, and we're seeing temperatures probably in the low 80s that time of day. So go back and construct our lifted parcel, and I'll use maybe 29 Celsius. And we get something like that. And we can see considerable cape up above that. See that? That's a huge amount of cape, indicating very strong vertical velocity in any storms that do reach that upper part of the troposphere. And here's the LCL right there. Here's the level of free convection, the LFC, and this is a cap right there at about 800 millibars. So you see how it bulges over, and that gives us just enough suppression to allow the storms to kind of percolate and strengthen and get a little bit more higher theta E going underneath. And then we can really realize the cape. We'll have a lifted parcel line that's way over to the right, and that will enhance the thunderstorm activity. And then the other factor is going to be your shear. See how we have west-southwest winds pretty predominant. And that contrasts quite a bit with the southerly winds at the surface. And remember, it's the surface through 1 kilometer layer that's really the key. Maybe surface to 2 kilometers, some go as high as 3, but it seems to be the surface through 1 kilometer layer that really counts for tornadogenesis. So without having a velocity azimuth display from the radar or some other form of data, profiler data. We don't know exactly how much shear is there, but we can definitely see we're kind of set up for something to happen there. And if we get mesolow development in this area, say we have a strong low forming in this area, that will tend to back the winds even further. You'll get more of a southeast to east-southeast flow, and then your storm relativity really goes up. Okay, so we got a lot to look at there. Let's go back to the large scale picture. This is a new chart that I've brought up here. This is thickness. Yeah, see right here. Let's see, 1,000 through 500 millibar thickness right there. And this is valid at 18Z. So this is the setup across North America. And what we're looking at is these red lines, these red dashed lines or dotted lines. By thickness, we're talking about a measure of density between 1,000 and 500 millibars, or roughly surface through 18,000 feet. So in other words, the lower troposphere. So this has given us an idea of what the temperature is as an average through that column. Now, moisture does factor into it to a certain extent, but the dominant process here is temperature. So as you might guess, this helps us find air masses. So these kind of act like mean isotherms for the atmosphere, the lower atmosphere. And we know from surface analysis that we want to put those fronts on the warm side of temperature gradients. And that holds true with thickness gradients too. So just to show you very quickly, we're going to want to put the front somewhere in this area. See, the strong packing is back north of it. So if we want to fine-tune that in just a little bit more, I'll draw those in real quick. We have a front there in southern Minnesota, another front through Wyoming, and then that carries back westward through California. So this gives us a rough idea where to find the front when we're analyzing in the Intermountain area, because that area tends to be very difficult. And we know that there's not any frontal activity. We shouldn't find anything like that down in Texas or the desert Southwest or even south of upstate New York. So things should be fairly barotropic in that part of the country. And we also find that the deepest polar air is way up north from far western Nunavut, say around Baker Lake, all the way up to Elamir Island. So this is kind of like the core of the polar air right now. So do we find any reflection on that front in the mountains? Let's go west a little bit. This is the chart from last hour. Okay, so we do find that front in South Dakota all the way to, looks like it slips south a little bit through Nebraska. See here around Grand Island, North Platte. Yeah, North Platte. All the way down to almost Denver, and then we can kind of follow that back up into Wyoming. So something like that. And then in Idaho, we kind of see the same thing. We can see that it's 81 degrees with a strong south wind at Salt Lake City, but we get out to Wendover here. Thunderstorms, north-northwest, gusty wind up to 49 knots. So that's going to be about 56 to 57 miles an hour. That's some ferocious wind. And north wind all through this area. So that marks the front in the western U.S. Let's see if we can track that into California. So remember, we expect to find the front kind of in this area here. So in the San Joaquin Valley, we see west-northwest winds. That's what we kind of expect to find behind a front. And then they become kind of indeterminate out in the Mojave Valley. See, we have a east-southeast wind here at Baker, I think, Barstow. So I'm probably going to want to put that front somewhere maybe here. It's very difficult to find, so maybe I might go with something like that right there. So that's a little introductory lesson where to find the fronts, and we're going to have to get familiar with that as we get into fall and winter. And speaking of fall, fall is almost here. It's going to be here tomorrow morning at 10:21 Eastern, 9:21 Central in the morning. So that's going to be the time of the equinox, and at that time the sun is sitting directly over the equator. And sunrise and sunset is about the same all up north and south through all latitudes. So the days are equal everywhere. Okay, let's go back to our charts here. And I think we're about ready to look at the forecast. So let's check that out. Okay, we're starting out with today's chart, and we're looking at precipitable water in purple and green. And then the black lines are isobars. So we just did our analysis right now. So we know that the front is located from Minnesota through Nevada and then down to California, kind of like that. And we can see that there's kind of a light push of polar air. Got this high here over Saskatchewan and one off the coast of Northern California. So these are the main highs driving that front. Then we've got one decaying low up in northern Quebec right there. So we're going to have kind of an occluded front up there. And then we've got Carl still wandering in a drunken haze out there northeast of Puerto Rico. And I think that is going to still be recurving to the north. I don't believe Puerto Rico is under the gun for that. But anyway, one thing I want you to watch here is the moisture. Look at this dividing line here in Texas of purple against green. This is the 1 1/4 inch precipitable water line. In other words, if you could squeeze out all of the water vapor into rain, you would get about 1 1/4 inches on the ground. So here's what happens over the next 24 to 48 hours. So we got a bit of a moisture surge into Texas there. So you can see that. So we've got probably a good chance of the sea breeze becoming very active in Texas. And up in the Minnesota and Iowa, looks like chances of rain and thunderstorms continue. So let's see, we're at about Friday. So now we're getting into the weekend, Saturday. Precipitable water's coming up to almost 2 inches in Texas. And that's starting to feed all the way up into Kansas. So it looks like rain chances are going to be coming up all through the plains, from Texas on northward to where there are any boundaries, maybe up in this region. So that's a possibility later on. Maybe even a possibility for severe weather. We'll keep an eye on that there. And here comes our push of polar air from the Pacific. So you see that blowing in here, and we get a front from Minnesota down to Texas. So that's going to be our big change coming on Monday. Now you can see it shoves the moisture back out to the Gulf of Mexico. So we're probably going to get a bit of a squall line come through Texas, probably Sunday night into Monday, and we'll get a little bit of clearing and cooler air. Highs should come down from the 90s into the 80s. And then we'll have a stretch of good weather here. It looks like they've backed off a little bit from that overrunning scenario. But the moisture tries to surge in again late next week as we get cyclogenesis out in the northern plains. And looks like the model has also backed off from that giant polar invasion the first week of October. And that's pretty normal. These models, they do tend to flip-flop. And it has also backed away from that hurricane scenario out in the Caribbean. Of course, you know, that could change too, but see that disturbance here coming right over the Lesser Antilles, moves out into the Caribbean, and it looks like it sweeps across Puerto Rico there in Dominica and then recurves north. So if that pans out, we're looking at October 1st to October 2nd for Puerto Rico. We'll watch that on the next couple of weathercasts and see what happens with that. Then a quick look at the upper air pattern. There's our polar front jet from California all the way to the northeast. We've got kind of a split flow pattern because there's another polar jet up in Alaska. Then the general trend for that is we get this big long wave ridge across the central U.S. That tends to keep us, that's one reason we're not getting much of a polar outbreak next week. This big long wave ridge kind of indicates that there's an abundance of warm air in the troposphere in this region, so things are going to be kind of mild. And we finally do pick up a bit of a long wave trough late next week. See that very large long wave? So this is probably where we're going to start seeing a big change in the patterns. So October there. First week of October. Looks like some fun there. Okay, and then just a quick look out in the tropics. Not much going on. Here's Lisa. Looks like that is recurving to the north. And then Carl is just continuing to wander around. Probably need to call an Uber for that guy. Get him out of there. And I think we're done here. And I've wanted to start working on a special feature here, throw in a couple features, so we can start using these weathercasts to learn a little bit more. So let me find my windows and let me kick off this next feature. So this will be our little geography lesson. Geography is very, very tightly tied into meteorology, and I think to really be a good forecaster, you really have to know geography and really have a passion for it. And the area that I want to focus on today is going to be the Four Corners area. You can see that's where Utah, Colorado, New Mexico, and Arizona come together. And this is all part of the Colorado River Basin. The Colorado River comes from the Grand Canyon northeastward through Utah, and we've got those beautiful caverns out there, natural bridge caverns, and then it winds its way up into the Rockies in Colorado. And this all forms the Colorado Plateau, I think. I would have to look back on that, but that's the big Colorado Basin there. An average elevation through here is about 5,000, so this is a big high plateau. And that becomes very important in the winter because we can generate polar air. Not very cold polar air, but we can generate a modest amount of polar air in this region. And so we have a tendency for high pressure here in the wintertime. So this is bounded on the south by the Mogollon Rim, and on the northwest by part of the Wasatch Range, and on the east by the Rockies there. And I've got a few slides here. Let me throw these up so you can see what that area looks like. If I can find my windows. Yeah, there we go. We have a lot of buttes out there. These are these very high spires where you get uneven erosion of the sandstone. And here's the Four Corners Monument right here. This is where all the boundaries come together, and it's in that very spot where the states meet. And you might think of it as desert, but it's actually got some vegetation. You can see some sagebrush here. And it's got some very beautiful scenery right there. This is a road that goes from, I think, around Four Corners up to southern Utah. And let me show you this. This is interesting. This is their geography, or I'm sorry, their climatology. You can see in the summertime, you normally get lows of about 58 at night, and then it gets up to about, hang on, let me reset the window here. Yeah, about 58 at night here. Hang on a sec. I'm getting confused here. 67 at night. They've got an average low and a mean minimum. What's going on here? Average high. I'm going to skip that until I can figure that out. That's kind of a weird way of setting up the data. But the main thing is that it is very cold there during the winter. You can see they've seen temperatures as cold as -8. There's averages all the way down to 12 at night, 15 degrees at night, so it is very cold there. And then I don't see a mean daily temperature, but that's probably around 30 or 40, so that's a very cold climate area. Anyway, that's ran on a little bit longer than I wanted to show you. I kind of wanted these to be short and sweet, like about a minute or two, so I think that's about all I got here. So I think we're done here. Thank you for watching. And let me check the chat, see if anything's up. Hello to everybody. To Ron, Mike, Lexi, and you guys. And see, there's a question about precipitable water. No, there's no level that guarantees rain for the area. That's mostly a function of your instability and whether you have like capping. And also you need boundaries to really set that off and flow over the boundaries. I mean, there's different processes for lift. These are just the basic ingredients, like basically what you have in the mixing bowl. So, but normally when we do run over 2 inches, it doesn't take much of anything to squeeze out precipitation. So that's when we start getting nervous, when you start going over 1.5 to 2 inches, because then your chance of precip really goes up, especially this time of year. Okay, I think we are done. So we will see you in the fall tomorrow. Have a good evening, and see you tomorrow at 8.